Hi everyone, welcome back to Generation STEAM. I am Sunny and I am a volunteer here at Generation STEAM. We are excited to teach you guys a new science topic and experiment. Before we go further, please like this video and subscribe to our channel if you are interested in more science topics. We put out videos for you guys twice a month, so remember to watch the next video we will put out on March 15th. 2 weeks ago, we uploaded a video on catapults. If you haven't watched it already, pause the video and go watch it. Today, we will be learning about and doing an experiment on a really cool and interesting topic, sound waves. We will be learning about what sound waves are and how it travels through air. We hope you have fun and learn something new. See you at the end of the video.
For our first fun fact, we are going to be learning about Leonardo da Vinci. As we start to talk about sound waves, we might also want to talk about the person who discovered sound waves, which is Leonardo da Vinci. Da Vinci first discovered that sound travels in waves back in the late 1400s to 1500s. As a scientist, Da Vinci was interested in how sound moves through different materials. Da Vinci was especially interested in underground and underwater acoustics and discovered the science in 1490 when he inserted a tube into water and was able to detect vessels by ear. Not only was Da Vinci interested in the logistics of sound and how it travels, he was also a musician and played several instruments. For our second fun fact, we're going to be asking the question, how does sound work? So sound comes from vibrations, and these vibrations create sound waves which move through mediums such as air, water, before reaching our ears.
Hi everybody, welcome to the demo part of our video. I'm going to be showing you guys today how we're going to make our cup phones. To start, we're gonna have 2 cups, a sharp object, anything will do. I'm just using a screwdriver here, and a piece of string. So to start, we want to poke a hole in the bottom of our cups. I have this little paper clip to help thread the string in easier, but we can just try to put this in like so. Thread in the string for the bottom of the hole. And you're going to want to repeat this on the other side as well. Alrighty. Cool. So we're almost done with creating our cup phones. Lastly, all we have to do is just tie a knot on the inside. Do that real quick. Got our knot tied, and we can start chatting with other people now. Cool.
Hi everyone. So for the explanation for the cup phone lesson, we're going to talk about how sound waves work. So sound waves are caused by vibrations of air particles. When you speak, you make the air around you move, and these vibrations are what create sound. When you speak more loudly, air particles around you move more, and that moves the particles around them, and so on. So this carries the sound waves a further distance because it's moving more and more particles. And this image right here is what you might have seen before. It's what sound waves look like in a music editing type software. And another thing to consider is, how does temperature of the air affect the speed of sound waves? So when you speak loudly, the air particles around you vibrate more because you've given them more kinetic energy. And kinetic energy is the energy of motion. Temperature is the measure of kinetic energy of particles, which means that at a hotter temperature, air has more kinetic energy. So that means the particles are moving more quickly. So sound waves have a greater speed at higher temperatures because they have more kinetic energy, so they're moving more. And another factor that might contribute to the speed of sound waves or how they sound is that if you've pulled the string between the two cups in the experiment more tightly, you're going to have more clear and direct sound because a tight string allows the vibrations to travel directly to the other cup through the string. But if you have a loose string, the waves and vibrations will travel less clearly through it, and so you won't have as clear of a sound, and that is why you might have that effect. So try out different lengths of string, different distances, and different tightness of the string and see if you can spot any results and differences.
Hi everyone! Thank you for staying with us till the end of the video. I hope you had a fun time learning about sound waves, and we hope to see you again in 2 weeks. Bye!